Hello everyone. Welcome to the mini lecture on electromechanical control technology. Today, we will explore the control principles of closed-loop systems. Next, we will explore the following two topics. Through today's lesson, I hope you can accurately describe the basic components of a closed-loop control system, including the setpoint element, comparison element, controller, actuator, controlled object, and measurement element. You should also understand and explain the control principles of closed-loop systems, which involve the steps of providing input, measuring output, comparing deviation, processing by the controller, and executing control. First, let's review the basic framework of a closed-loop control system. A closed-loop control system consists of input devices, controllers, actuators, sensors, and feedback loops. These components work together to form a loop, enabling the system to make real-time adjustments based on the actual state of the controlled object. Next, let's learn the control principles of closed-loop systems. 1. Basic components of a closed-loop control system. A closed-loop control system generally consists of the following basic components. 1. Setpoint element. The setpoint element generates the system's input signal, which is the desired output value. This input signal can be either constant or variable. 2. Comparison element. The comparison element compares the measured output value with the given input value and calculates the deviation signal. The comparison element is usually implemented using integrated operational amplifiers, op-amps, or similar circuits. 3. Controller. The controller is the core part of the closed-loop control system. It calculates the control signal based on the deviation signal in the system model. The design of the controller is a key part of the closed-loop control system and directly affects the system's performance and stability. Common controller algorithms include PID control, fuzzy control, and neural network control. 4. Actuator. The actuator adjusts and controls the controlled object based on the output signal from the controller. The actuator can be various types of motors, control valves, hydraulic motors, etc. The precision and response speed of the actuator significantly affect the system's performance. 5. Controlled object. The controlled object is the physical system or device that needs to be adjusted and controlled. The characteristics of the controlled object determine the design approach and the effectiveness of the control system. 6. Measurement element. The measurement element monitors the output value of the controlled object in real time and converts it into an electrical signal to transmit to the comparison element. The accuracy and reliability of the measurement element have a significant impact on the system's performance. Common measurement elements include temperature sensors, pressure sensors, and flow sensors. In addition, a closed-loop control system may also include some auxiliary elements, such as correction elements, compensating components, filters, and limiters, to improve system performance or meet specific control requirements. 2. Control principles of closed-loop control systems. The working principle of a closed-loop control system is based on the feedback principle, which controls the system according to the information about changes in the system output. Specifically, a closed-loop control system achieves control through the following steps. 1. Given input. First, the system requires a given input signal, also known as the setpoint or reference input. This input signal represents the desired state or output value the system aims to achieve. 2. Measured output. Next, the system uses sensors or other measurement elements to monitor the output value of the controlled object in real time. This output value reflects the actual current state of the system. 3. Comparison of deviation. The system then compares the measured output value with the given input value and calculates the deviation between the two. This deviation represents the difference between the system's current state and the desired state. 4. Controller processing. The controller processes the deviation signal in the system model to calculate the control signal. Common controllers include proportional controllers, integral controllers, and derivative controllers. 5. Execution control. Finally, the actuator adjusts and controls the controlled object based on the output signal from the controller. Actuators can be various motors, control valves, hydraulic motors, etc. During the control process, the system continuously compares the output value with the given value and adjusts based on the deviation signal until the output value reaches or is close to the given value. This feedback-based control mechanism allows closed-loop control systems to achieve higher control precision and stability. Through this lesson, we have gained a deeper understanding of the control principles of closed-loop systems. We know that a closed-loop control system uses feedback to achieve precise control of the controlled object, offering high control precision and good stability. It consists of key components such as the setpoint element, comparison element, controller, actuator, and controlled object, with each part playing an important role. In practical applications, we need to select the appropriate controller algorithms and component configurations based on the characteristics of the controlled object and control requirements to achieve optimal control effects. Lastly, please think about this lesson and complete the following exercises to consolidate today's knowledge points and deepen your understanding. That concludes our lesson for today. See you in the next lesson.